Good afternoon. We are going to talk about a concept that is a little bit problematic for the high school students especially, and some college students as well. That is called the mole. The mole is the unit of substance, and there are some facts about the mole. The mole is just a number, a very big number. We are going to see the value in a few seconds. The mole is a super big number, and it's also, as we said, the unit of amount of substance, and by definition is the number of atoms present in 12 grams of carbon-12. So, in other words, if you take your periodic table, you're going to see that 12 is the mass in atomic mass unit that appears in the periodic table for carbon. In this case, it's going to be not exactly 12, but if we take 1 mole of atoms of carbon-12, we are going to have exactly 1 mole of atoms in that amount. Because the atoms are so small, the number of atoms present in 1 mole of atoms is very, very big. And it's so big that if we count the amount of glasses of water in all the oceans, we are not going to get to that big number that we are going to call the mole. Remember that the mole is like a dozen is 12, a mole is just a number. The numerical value is 6.02 with some other decimals, but we don't care about those decimals right now. It's just the concept that I want you to grab. It's 6.02 and followed by 7 sets of 3 zeros. That means 21 zeros. If we express that in scientific notation, it's going to be 6.02 times 10 to the 23rd atoms or molecules or particles. What does that mean? That means that if we get 12 grams of carbon, we can count the amount of atoms that we have, and actually is this number. 1 mole of carbon atoms is going to be equals to 12 grams, because this is the mass in the periodic table expressed in grams, and that is going to contain 6.02 times 10 to the 23rd atoms of carbon. We can even expand that to another atoms. In general, if we get the mass of the periodic table expressed in grams for any other element, we can say that in that amount of grams, we are going to have 1 mole of atoms, or 6.02 times 10 to the 23rd atoms of sodium in this case, because we are talking about 23 grams of sodium. If we want to represent 1 mole of iron atoms, we are going to represent 56 grams of iron, because that is the mass of the iron in the periodic table, and this is going to be also 6.02 times 10 to the 23rd iron atoms. Now, try to remember something. Each atom is different in mass, so when we get the same amount of each one, the masses are going to change, but the amount of substance is going to be the same. So, the concept of the mole can be expanded even to molecules. When we have, for example, 1 mole of atoms of oxygen, we said that we express the mass of the periodic table of that element in grams, and we are going to have 1 mole of, or 6.02 times 10 to the 23rd atoms of oxygen. But we can expand that to oxygen gas. So in this case, it's going to be the same amount of particles, but in this case, instead of atoms, are going to be molecules. Be careful with that. Don't get confused between molecules, M-O-L-E-C, with mole, M-O-L. This is the unit that represents this amount of molecules or this amount of atoms. 1 mole of atoms is this number of atoms. 1 mole of molecules, in this case, molecule of oxygen gas, is going to be the same amount of molecules. How do we calculate the mass of that? Well, we just add up all the atoms that are present with the masses, and we are going to have, in this case, 32 grams for the oxygen gas. Or if we have ozone, since the molecule of ozone is made of 3 atoms of oxygen, the mass will correspond to 48 grams of oxygen. Please notice that every single time we have the same amount, because we have 1 mole. It's like 1 dozen, it's going to be 12, 1 dozen, 12, 1 dozen, 12. It doesn't matter which is the particles that we are counting. Every single time we are going to have the same number. Even further, and this is very useful for us, we can expand that to molecules that are made of different type of atoms. For example, in the case of the molecules of water, we have 2 hydrogens, and the mass in the periodic table is 1. So 1 atomic mass unit is the mass of each hydrogen, and then oxygen is 16. We have it 1 time the oxygen and 2 times the hydrogen. That is going to make a total of 18 atomic mass units for 1 molecule of water. But if we express the mass of 1 mole instead of 1 molecule, we are going to have 18 grams. So, rule of thumb, you get all the elements that you have, you take the masses in the periodic table, you multiply them by the amount of times that appears in the formula, and you add up all the masses. That is going to be the mass of 1 mole of molecules. So it's going to be 6.02 times 10 to the 23rd molecules. Here we have another example with the sulfuric acid. Hydrogen appears twice, and the mass is 1 atomic mass unit. Sulfur is 32 the atomic mass units, and you can see that it appears only once in the formula. And then you have oxygen that appears 4 times in the formula. So 16 times 4 is 64, 32 times 1 is 32, 1 times 2 is 2. We add them up, we have 98. 98 grams is going to be 1 mole of molecules of sulfuric acid. How many molecules are going to be present here? Well, it's 1 mole, so it's 6.02 times 10 to the 23rd. Okay? Now, even if we have ionic compounds, we can expand that. We are not going to have 1 mole of molecules. We are going to have what we call formula units, which is the same concept as molecule, but it's not for covalent compounds. So 1 mole of sodium chloride, in this case, sodium appears 1, chlorine appears once, so we have 58.5 is the mass. So 1 mole of sodium chloride is going to be 58.5 grams of sodium chloride. It's the same as 6.02 times 10 to the 23rd formula units in this case. In the next video, we are going to see how to make calculations to pass from moles to grams, from grams to formula units or atoms or molecules, whatever you need. Okay, using this relationship, you can resolve any of the concepts that are going to see in this unit.